Hello and welcome back to another video. Here we are going to solve next two questions from specimen paper for examination from 2020, and it is pure mathematics 3. And here's the question number 3. A part, sketch the graph of y is equal to modulus 2x minus 3. So I'll draw it through the software, but I'll tell you how it is to be drawn. First of all, we'll find the root of this, because modulus x is going to be x if x is greater than or is equal to 0, or it is minus x when x is less than 0. Similarly, we'll break it through 2x minus 3 is greater than or is equal to 0. So the value where it will intersect the x-axis is going to be this is equal to 0, means x is equal to 3 by 2. So the part of the graph y is equal to 2x minus 3 will reflect in x-axis through x is equal to 3 by 2. Whatever part is going below the x-axis will reflect it. Let me draw it here. So here's the graph. We can see it is going to pass through 3 by 2, that is 1.5, and this was the line y is equal to 2x minus 3, but we have it's being reflected from the x-axis. So this is the graph of y is equal to modulus 2x minus 3. I hope it is clear. Let's do the second part of this question. And here's the B part. Solve the inequality to 3x minus 1 is greater than modulus 2x minus 3. So whenever we have one modulus function and another is a straight line, and we need to solve the inequality, the best way is to sketch the graph of both the functions. And in maximum cases we have this y is equal to modulus 2x minus 3 graph in the previous part, so we only need to draw the y is equal to 3x minus 1. So from there we can see what are the lines we are going to focus on. So I'll draw it here. Here's the graph. This graph is y is equal to modulus 2x minus 3. And this line is y is equal to 3x minus 1. So we can see, because its y-intercept is minus 1 and the gradient is going to be 3. So 1, 2, 3 and then 1. So that's the line, and the inequality we are searching where 3x minus 1 means this blue line is more than 2x minus 3. So we can see that here this blue line is below the red line. But after this point we will get red line below always means modulus of 2x minus 3 will always be less than 3x minus 1. So we need to focus on these two. This intersection means y is equal to minus times 2x minus 3 because it's a reflected line, and the line y is equal to 3x minus 1. So we need to focus on these two part. So it is going to be 3x minus 1 greater than minus times 2x minus 3. We need to be very careful here, because it's why I have taken minus, because this line was y is equal to 2x minus 3. Once it was reflected from this, it become y is equal to minus of 2x minus 3. That's why it is a modulus function. So we will find the intersection point by solving this, and it is going to be 3x minus 1 minus plus 2x, and this plus will come here and it would become minus 3 greater than 0, or it is going to be 5x is greater than, I'll take this minus 1 minus 3, that is minus 4 to the other side, it will become plus 4, or we can say x is going to be greater than 4 over 5. So that's the solution. If we'll solve by the usual method by squaring both the sides, we will get two roots. Then we have to decide which one we are going to ignore. So this is the best way. Inequality, and one side there is a modulus function and there is no modulus function to the other side. We sketch the graphs and we will decide from there. I hope it is clear. Let's do the fourth question. And here is the question number 4. The parametric equations of a curve are x is equal to e raised to the power 2t minus 3 and y is equal to 4 ln t. where t is greater than 0. When t is equal to a, the gradient of the curve is 2. Means at t is equal to a, this 2 is going to be dy over dx. So dy over dx, that is gradient of the function curve, is 2. And the first part is to show that a satisfies the equation a is equal to half times 3 minus ln a. So first of all we'll find dy over dx. So dy over dx, by chain rule we can write it as dy over dt multiplied by dt over dx, or we can write it as dy over dt divided by dx over dt. So let's find dy over dt first of all in order to substitute. So dy over dt means differentiation of this function with respect to t, will get 4 over t, and similarly dx over dt. From here we can see it is e raised to the power 2t minus 3, then it is going to be e raised to the power 2t minus 3, and by chain rule it would be differentiation multiplied by differentiation of 2t minus 3, which is 2. So substituting the value, we will get dy over dx as 4 over t, and divide by this, so it means 1 over 2 times e raised to the power 2t minus 3. So these two got cancelled, and it is 2 over t times e raised to the power 2t minus 3. So that's the dy over dx, that is the gradient of the curve. Now at t is equal to a, dy over dx equals 2. So it means this 2 over a times e raised to the power 2a minus 3 is equal to 2. These two got cancelled. By cross multiplication, we'll get 1 upon a is equal to e raised to the power 2a minus 3. And then in order to remove this e, we will take the log of both the side, and that is natural log. So we will get ln 1 over a is equal to 2a minus 3, which means 2a is equal to 3, and it is ln 1 over a means minus ln a, so it can be written as minus 3 ln a, because ln 1 over a can be written as a raised to the power minus 1, and which would be ln, and then it is minus ln a. So a we can write is as 1 upon 2 3 minus ln a, means a satisfies this equation. That is the question. Let's do the b part of it. Here's the b part. Verify by calculation that this equation has a root between 1 and 2. So a was 1 over 2 times 3 minus ln a, so we can make a function in a as a minus 1 over 2 times 3 minus ln a. Just take this one side and take it as a function. Now we'll check for f of 1 and f of 2. If they have opposite sign, it means the root will lie between 1 and 2. So at 1, when a is 1, it is 1 minus 1 upon 2 times 3 minus ln 1 is always going to be 0. So it is 1 minus 1 minus 3 by 2, which is 2 1s are 2 minus this, so it is minus 1 by 2, negative value. And when we'll put f of a value as 2, we'll get 2 minus 1 upon 2 times 3 minus ln 2. This value is going to be 2 minus 3 by 2 plus ln 2. ln 2 is a positive quantity, and 2 2s are 4 minus 3, it is going to be 1 over 2 half plus ln 2, which is going to be a positive value. And since f of 1 and f of 2 have opposite sign, it means, this means root lies between 1 and 2. That's it. Let's do the last part, C part of this question. Here's the C part. Use the iterative formula an plus 1 is equals 1 over 2 3 minus ln a n to calculate a correct to 2 decimal places, showing the result of each iteration to 4 decimal places. So from the previous part, from the B part, we have seen the root of this lies between 1 and 2. So we can take the initial value a1 as, let's say, 1.5. We can take even 1.2, 1.3, anything between 1 and 2. So I'll take a1 first iteration as 1.5. So from here we will get a2 is equals 1 over 2 3 minus ln 1.5. and now we are going to use calculator. We'll replace this value, exactly this value, and first of all we will store a1 as answer key, and then we'll write a2 means next value as, we'll calculate 1 by 2 3 minus ln answer, so that we can get the next iteration just by pressing the answer button. So let's calculate this, and this value is, till 4 decimal places we need to write, and it is 1.29726 and so on, and hence the next value a3 would be 1.3698 and all. Fourth iteration is going to be again by pressing equals button, we'll get 1.3426 and so on. a5 is equal to, it is 1.3526 and so on, and we can see the pattern, it is revolving around 1.35. so we can take the answer correct to 2 decimal place of a as 1.35. Even we can check for one more value, a6 iteration, it is going to be 1.3489 and all. From here it is very much clear that it is the, till 2 decimal places it would be 1.35. So that's it for this video. So we'll solve the next few questions in the next video. Till then, thank you so much.